Welcome back. Let's try one more example. Here is a matrix, find its determinant. Notice, if you remember, we can use any row or any column to find the determinant. This particular column is of interest to me because it has two zeros, which means my calculations will be fewer. You will see in a minute what that means. Notice column 2 has two zeros. So let's expand on column 2. That is, determinant of A is -3 times the cofactor 1, 2. Cofactor 1, 2 because that's the location of -3. Plus 0 times the cofactor at 2, 2 because that's the location of 0. That's 0. Plus 0 times cofactor at 3, 2 because that's the location of this 0. So you see, A22 and A32 are cofactors. No matter what calculations you get, you're going to multiply by 0. So you don't need to calculate these. Okay? We do not need to calculate A22 and A32 since they are being multiplied by 0 anyway. Eventually they are going to be 0. So all we need is A12. What is A12? That's this location. Remove its row, remove its column. What is left? 1, -1, 4, 3. 1, -1, 4, 3. Find its determinant, that is its minor, times -1 to the power 1 plus 2. What are 1 plus 2? The indices that you are looking at. So -1 to the power 1 plus 2, that's -1 to the power 3. Determinant of this guy, 1 times 3 minus -1 times 4. 1 times 3 is 3. Negative of negative is positive 4. Notice -1 to the power 3 is a -1. So eventually you get -7. That was the cofactor at this position, 1, 2. Determinant is -3 times its cofactor. -3 times -7, that's -21. Remark, to evaluate determinant of any square matrix, identify any particular row or column with the greatest number of zeros and expand through that row or column for ease of calculations. Okay? So you can use any row or column as long as you keep track of the indices. Okay? So here is an important theorem. Let A be an n by n upper triangular or lower triangular matrix. Then determinant of A is simply A11, A22, A33, ANN. That is product of the diagonal entries. We prove the result for upper triangular matrix A as the proof of a lower triangular matrix is similar. Okay? Let Aij be upper triangular. What does that mean? AI1 is greater than 0 for I greater than 1. That is, the first column is full of zeros with A11 potentially non-zero element. Okay, first column. Likewise, so you may use the column 1 because it's full of zeros. So A11 times the cofactor of A11. So remember, if you imagine an upper triangular matrix, you're dropping the first row and the first column. So you really have a smaller matrix, M11. Okay, cofactor is -1 to the power 1 plus 1. That's even power. So A11 cofactor is same as determinant of M11. Now M11 is again an upper triangular matrix. Hence its determinant can be calculated the same way. Again, you are going to take its top left entry using expansion along column A22. Determinant of M11 is A22 times a smaller matrix. Keep going further. Okay, so let's see. That's an upper triangular matrix. Okay, all the entries below are 0. By the way, this is incomplete. You need a smaller matrix here. Okay, so I'll fix that error. But regardless, determinant of A is all along the diagonals. So let's understand it using a picture. This is an upper triangular matrix, so everybody below is 0. So because this has the maximum number of zeros, I expand my determinant along column 1. So A11 times the cofactor from here, the smaller one. Just drop the first row, drop the first column. What you get again is an upper triangular matrix. How do you calculate its determinant? Use this first column here times A22, drop this, drop this. Next, A33, drop this, drop this. Keep going until ANN, it should be NN. Okay, so determinant of A11, A is A11 negative 1 to the power 1 plus 1, determinant M11, that is A11 determinant M11, A11 A22 determinant M11 and keep going until you have only NN. It should be N here. It's a square matrix. Okay, which brings us to homework problems. These are your homework problems. Okay, so I'll fix a few typos here. That should be NN, and this should have a smaller matrix. It's not just A22. Okay, so here is the collection of homework problems. Let's see you in class.